All right, section 1.3, quantifiers, Venn diagrams, and valid arguments. So topics for this video, for this section: quantifiers, quantified statements, universal quantifiers, existential quantifiers, negations, counterexamples, Venn diagrams, and valid arguments. So with that said, let's go ahead and cruise along. I'm not actually going to go into each one of these things. They're pretty straightforward. So just kind of take notes on these. You have a 3-slide PDF that you can print out that has the resources on there. So kind of have those. So universal, all, every, each. Got some examples. We have some universal quantifiers that can be switched over conditional statements. So this just kind of helps you just like go back and forth to remember, like, conditional statements are if then statements. So let's just pull this up quick. So, like in a conditional statement, you have if and then. And then, if we put it as a universal qualifier, we're just saying all illegal. So these can go either way. So if your act is illegal, then it's immortal. All illegal acts are immoral. I think I just said immortal. Sorry about that. So that's just kind of like the main idea there. Just some examples for you to go off of. All right. So a few more things about existential. Is there existential? There's some. Oops, sorry about that. There's some, there exist, or there exists at least one. So we got some examples of those. And then this brings us down to a situation where we're looking at like these cases where we're trying to negate something. And so when we look at negation, the thing we want to think about is like, look at all the possible combinations. So in case number one, we actually have all letters that are vowels. So we put that out there and we've got the all part. In case number two, some of the letters are vowel, but not all of them are vowels. And the last one, none of them are vowels. So from there, what that allows us to do is that we kind of can look at a truth table. And with that truth table, we can look at it and say, okay, so we take our original statement that all letters are vowels. Then in case one, that's true. Case two is false. Case three is false. So that's our original scenario. So remember, what we're trying to do here is negate it. We're trying to find, like, not necessarily the opposite, but just the negation of that. And so we run through there and we have three possible statements that we can create as negations for our original statement. And the tricky part about this is that when we take those and negate them, we think about it. So like the first one, no letters are vowels. That would be false for the first one. No letters are vowels. That would be false for the second one. And no letters are vowels. That would be true. So in that case right there, we're able to make a truth statement based upon the way we rewrote our what we thought was a negation of the original. So the next negation is all letters are not vowels. So once again, false, false, and then the last one, true, because all letters are not vowels. And so once again, we have what we think is a negation, but it's not really working because it's not the opposite of the original statement. So our original statement had truth value of true, false, false. And so far we have false, false, true. So we have its opposite on the first one, but in the second one, it has the same truth value. On the last case, it's opposite. That's good. So, but we still have this problem in the middle where we have the same truth value. So we try one last one. Some letters are not vowels. So the negation of all letters are vowels is some letters are not vowels. So we test it. Some letters are not vowels. That's false because all of them are vowels. Some letters are not vowels. That's true because two of them are not vowels. And some letters are not vowels. That's true. All of them are not vowels. And so that is actually a negation because the truth value is exactly the opposite of the original statement. So we take a look at this. We go from true down to false. We go from false down to true. And we go from false down to true. So that's how we're going to find a negation, is we look at these different possible statements that we can write as the negations. Sorry about that. What am I doing here? I don't really know. There we go. Clear selection. Boom. And then cruise along. All right. So we got some more examples here. You can take a look at those and use them as a guide when you're doing your homework. All All right, counterexamples. So just some things to kind of read about a counterexample. And the kind of the main thing is that existential quantified statement is false. You must show that that is false for all possibilities, and so forth and so on. So like I said, you can read this and kind of as references. Venn diagrams are the one that I wanted to kind of look at a little bit more. So like if we're trying to make a Venn diagram, all dogs D are animals. So D, all dogs, would fall inside of all animals. Some kindergarten students, K, are able to read. So notice K is kind of on the outside of that. So it's not inside. So R is all the kids that can read. And then K would be kindergartners. So some of them can't read and some of them can read. So these are the kindergartners in here that can read. So that's some. It's awesome. No cat is a dog. So those are two different species. So we have dogs in one category and cats in another category. So Venn diagrams. And then valid arguments. With valid arguments, what happens is that we have these like three statements. And so like it's like all leghorns are chickens, all chickens are chickens, and those are our premises. So out of those premises, we have a conclusion. Therefore, all leghorns are fowls. So one way of doing this is to go ahead and do it through a Venn diagram. If we use a Venn diagram to do this, then what happens is we kind of go through and say, all right, all leghorns are chickens. So you'll notice that L is inside of the C. All chickens are chickens. So C would be inside of C. Then therefore, all leghorns are fowls. And so that makes a true statement. If we go to the next one, we have all football players are excellent students. So S stands for students. F stands for football players. Manuel is a football player. Therefore, Manuel is an excellent student. All right. So this would be another example of a true or a valid argument because of the fact that Manuel is a football player, therefore he's inside the students, and then this is a true statement. And we have one more that is a false argument that is not valid. So some football players are excellent students. So we have students right here. We have football players. We have a small bit, or we don't really know. It's just like for visual purposes that are inside this guy right here. Thomas is a football player. Therefore, Thomas is an excellent student. Well, that's not necessarily true because Thomas could be here. He could be in this part of the circle. If he's in this part of the circle, then he's not in the student part of the circle. So therefore, this is not a valid statement. So that gets us through, I think, all of this section. Yep. I was just thinking, I'm going to hit pause for just 1 second. All right, sorry about that. I was just double checking that the homework told you to use Venn diagrams for your valid argument problem. So this will help you with 1.3. Reach out to me like anytime. I always suggest if you have any questions. Thank you.